Okay, this is the 4-2 notes for Algebra 2. We're looking at multiplying polynomials. This is pages 365 to 371 in your textbook. If you're doing the paper assignment, it's pages 372 to 377, numbers 1 through 7, then 9 and 10, and then 16 through 21. Okay, so we're looking at multiplying polynomials. Couple of things to remember is that a binomial is a polynomial with two terms. A polynomial is something that's being added together, but when you want to multiply them, you're actually multiplying the pieces together. So volume is length times width times height. So you have a polynomial times another polynomial. I'm not going to go through the example on this page. I actually marked it off. If you're using blocks, it makes a lot more sense, but since I do not have blocks to work with, I'm not going to do that one. Okay, so there are a couple of ways that we can do multiplying polynomials. One of them is the side-by-side method. This is a situation where you're going to distribute and then add. So we're basically doing an x times 1, x times -4, and then x times 2x squared, which is what they show in this first group. And then they do 2 times all of the components, and then you simplify by gathering like terms, and you get your answer. That works fine if you are very, very meticulous. If you're not very meticulous, it can get to be a bit messy. The second method is called the stacking method. I prefer this because it's reminiscent of multiplying when you were in elementary school, where you would do 3 times 1 is 3, 3 times 2 is 2, add a 0, 4 times 3 is 12, carry the 1, 4 times 2 is 8, plus 1 is 9, and then you would add. The same method is going to be set up. The only difference is you're going. Okay, so the first way that you can do this is side to side, also known as double rainbow or distribute and add. So basically, I call it the double rainbow because if you notice, it looks like I've made a rainbow here and a rainbow down here, where I'm showing you're going to multiply 3 times each of the pieces inside, and then you're going to multiply 2x times each of the pieces inside, and I've shown you that written out. Then you just do 3 times 4 is 12, etc. And then you will use the addition, in this case, side-to-side method, to add the pieces that go together. So 10x cubed is the only one like it, so it gets written down. -14 and positive 15 get added together. That's positive x squared. -21 and 8x get added together. That's -13x, and then 12 is by itself. Okay, so that's one way. Again, I've rewritten it again, doing stacking, and it is important to rewrite each of your groups, each of the bubbles, excuse me, in descending exponential order, standard form, greatest exponent to the least. And then also, it helps to line up underneath. So number being underlined under number, x under x. Now we simply multiply like we did when we were in elementary school. 3 times 4 is 12. 3 times -7x is -21x. 3 times 5 is 15x squared. It is important you put plus signs in front of positive numbers and minus in front of negative numbers. And then I add in a 0 so that I'm saving that place and moving over because this place has been used up. We need to move over. 2x times 4, 8x, and that's a positive in front. 2 times -7 is -14. X times x is x squared. And then 5 times 2 is 10. X squared times x is x cubed. And now we simply add down. And again, this is the way I remember to add rather than thinking that as a positive sign. Okay, the last method is one that you might have learned in Algebra 1. It's called the box method. It works really well when it's a 2 by 2. When it gets to be a 2 by 3 or a 3 by 3, it can get a little messy. But the idea is you take your biggest one, go across, and then your smallest one and go down. And it's really important that the minus sign sticks to the number, so it becomes a -7 and a +3. That way, when you're looking at it, you're reading 5 times 2 is 10, x squared times x is x cubed. -7 times 2 is -14, x times x is x squared. If you read it that way instead of as a minus sign, it will keep you from missing negatives. 4 times 2 is 2x, 8x. And then 5 times 3 is 15. X times squared times 1 is x squared. Negative 7 times 3 is negative 21 times x. And then 4 times 3 is 12. Now, so you multiply around the corner, and then you add the diagonals, which I've highlighted. And then you write down your ends on the outside ends. And that gives you your answer. Okay, so they do a example of a word problem. Notice that when they're doing it, they are using the stacking method, especially when it's dealing with a bunch of decimals. That kind of keeps things clean. That's the only thing that I'm going to suggest you recognize. And then when it asks you to find the polynomial of the model, they're talking about cost. So basically, you want to know the total cost is the product of the dresses made times the cost per dress. So that's how you know you're multiplying. So you're looking for the word product. I have worked out number 5. And again, the idea is that you're trying to find the model for the cost, the total cost of toys being made. So it's it is the number of toys times the cost per toy. So that's how we know what we're doing in terms of multiplying, because the word per is what gives us away. So the total cost is the toys times the number of cost per toys. And again, stacking method works really well. If you want to do it with the box method, that would be the second choice, I would say. But I would really recommend not trying to do a side-by-side method when you're dealing with decimals. It can be very nasty, messy business. Okay, the next thing that this chapter is talking about is polynomial identities. These are the things that we used back in algebra to be able to kind of shortcut doing some factoring, but it makes it really cool when you want to try to impress somebody about doing a big number multiplication without actually using a calculator or a piece of paper. So we know that x squared minus a squared, which is the difference of two squares, is x plus a times x minus a. That's the difference of two squares. We can also use another polynomial of the x plus a parentheses squared minus x minus a parentheses squared is 4 times a times x. So those identities are things that helps us to kind of shortcut our math. They go back all the way back to Greek times. Okay, long before they had calculators, this is how they actually did long math. So the first couple of things they want you to do is to prove that they are true. And I have worked through that for number 6. A squared minus b squared, a to the 5th minus b to the 5th is a minus b times this particular polynomial. So using stacking, I have done the math, and you can see that all of the middle pieces add up to 0, and you end up with a to the 5th. Sorry, that's supposed to be a negative. Minus a to the b to the 5th. That was a mistake. Okay. All right, so now they want you to use a given polynomial identity to find 37 times 43. So there's a trick to this. It's not as hard as it looks. The first trick is add the two numbers that you want to get and then divide by 2. Find their average. So the average of these two is 40. That's going to be your x value. Then to find your y, you do 40 minus whatever y it is, should be giving me 37. So 40 minus 37